Did you know that using outdated Wi-Fi security protocols like WEP could leave your entire network vulnerable to hackers in just minutes? In today's connected world, securing your wireless network is more critical than ever. But how do you choose the right protocol and authentication method to keep your data safe? In this video, we'll break down everything you need to know about Wi-Fi security, from WEP and WPA2 to Radius and TACACS plus authentication servers. By the end, you'll have the knowledge to lock down your network like a pro. Ready to secure your Wi-Fi? Let's dive in. Wi-Fi security protocols and authentication methods. And we start this course on Wi-Fi security protocols and authentication servers. As you know, wireless communications are transmitted by radio waves, and therefore, if they were not encrypted, and anyone with a Wi-Fi card could intercept and read our data. Encryption is simply the conversion of data from a readable format to an encrypted format in order to make it confidential. In the context of wireless transmissions, we use encryption and authentication protocols to guarantee this security. And we start this first part with the WEP protocol, which is the acronym for Wired Equivalent Privacy. WEP is simply the first protocol set up to secure Wi-Fi connections. It uses a secret key that ranges in size from 40 to 104 bits. In fact, the WEP protocol should no longer be used today because it suffers from several security flaws, and with the right software, you can force the key in less than 5 minutes, and that's why it's been nicknamed the Weak Encryption Protocol. In summary, never use the WEP protocol even if your network interface allows it. In 2002, WPA was introduced to replace WEP, but the purpose of this protocol was to provide a quick solution to WEP security problems while remaining compatible with current hardware. As a result, WPA is more of a transitional solution to correct WEP security flaws. The communication protocol used by WPA to fix WEP vulnerabilities is called TKIP, and it requires a 256-bit key. As with WEP, it uses an encryption method called RC4 and offers better management of encryption keys, which makes WEP attack methods impossible. A sequence counter that avoids replay attacks. A replay attack is when a hacker records the TCP/IP stream of your connection and rebroadcasts it as is. In our situation, this technique was used to crack a WEP key, but other uses are possible. And finally, the addition of a 64-bit integrity message that certifies that the TCP/IP flow has not been modified on the fly. As we have seen, WPA was only an emergency response, and it was in 2004 that WPA2 pushed the security of Wi-Fi communications even further. The communication protocol will then be the CCNP, which uses a block encryption algorithm called AES. RC4 was a stream encryption algorithm that requires little computing power for encoding, decoding. Block encryption is better, but requires more power, which is why WPA2 cannot be used with WEP/WPA interfaces. It can be said that the advantages of CCNP over TKIP are that it allows better encryption of data, it also allows user authentication, and finally, it has an access control mechanism. At home, you probably use the personal version of WPA2 called WPA2 PSK. A single 256-bit key is shared for all users, and this key is called a pre-shared key, PSK. In companies, we prefer to use WPA2 Enterprise, and this version allows the authentication and access control of users to a Radius or TACACS plus server that we will see in more detail below. Although it is not on the program of this certification, we can specify that there is now a new version of WPA which is WPA3. Although hardware using this new security protocol is available, it is still not widely adopted. We continue with authentication methods that allow users to be identified and granted access accordingly. As part of corporate Wi-Fi security protocols, user access is done through an authentication server that can also be called an API server for authentication, which is the identification of the user. Authorization, the server comes to frame what the user can or cannot do, and finally audit or accounting, which quantifies the way in which the user uses resources. For example, the duration of connection or the amount of data used. To prove one's identity to the server, one most often uses an identifier that is considered public and a password that is secret. And for added security, one can use a multi-factor method that requires several elements to prove one's identity. In general, 2 elements of this list are used. Something you know, a username and password, for example. Something you own, like an RFID badge. What you are, for biometric identifications, so a fingerprint, for example. And where you are, using GPS positioning. We will now look at the 2 most common types of authentication servers. Radius, which stands for Remote Authentication Dial-In User Service, which is probably the most popular authentication service, as it is available on all operating systems. In particular, it makes it possible to centralize authentications for routers, switches, firewalls, VPNs, and it is the protocol of choice for networks using the 802.1x standard. When it is not possible to use Radius, well, most often TACACS is used. TACACS stands for Terminal Access Controller Access Control System, and it is an older protocol and is common under Unix networks. TACACS was created in order to control authentications on ARPANET, which is in a way the first version of the Internet. So, it's a very old protocol. There is a more recent version called TACACS,